Hello everyone, Praveen this side. I hope you guys are doing great. And if you're not, don't worry, keep hustling because one day you will definitely reach the heights of greatness. So today we are going to solve the problem maximum circular subarray sum, which is a hard level problem. So the problem description says given an array of integers ARR in a circular fashion, find the maximum subarray sum that we can get if we assume the array to be circular. That is, we have been given an array in a circular fashion. From that, we need to find the maximum subarray sum. Now, how can we determine the array to be circular? Suppose we have an array with few elements in it. Now, if we are at the last element, we can jump to the first element of the array so that we can maintain the circularity. But in our traditional array, if we reach the last element, we can't iterate back to the first element, right? But that is not the case in the circular array. So you have understood what the circular array is, right? Now let's see the examples. In example 1, the array is this and the output is 22. The explanation says starting from the last element of the array, that is 12, and moving in a circular fashion, we have the maximum subarray as 12, 8, minus 8, 9, minus 9, 10, which gives the maximum sum as 22. That is, we have started from this element and have expanded our window till here. That's why we got the sum of 22. And in the example 2, the array is this and the output is 23. Now the explanation says the maximum sum of the circular subarray is 23. The subarray is 765 minus 4 minus 110. Now we see in example, the subarray is this part and then this part, right? Again following the circularity principle. And finally, in the last example, the array is this and the output is 52. The explanation says circular subarray 765 minus 4 minus 1 minus 1 40 has the maximum summa which is 52. So the subarray in our array is at 765 minus 4 minus 1 minus 1 40. So we have understood all the examples, right? Now we'll take the example 1 as a reference and we'll try to take few observations from it. So our aim is to find the maximum circular subarray sum, right? So what is the first observation that hits in our brain when we were dry running example? To generate all the subarrays, and from all the subarrays, whichever subarray gives the maximum sum, we'll consider it. But there's a catch of finding all subarrays. We can consider the circular subarrays too, right? For that, let's consider index 4 as the starting pointer, right? Now we'll take this window and check whether it is maximum sum or not. Then we'll expand this window. Then again expand this window. Now, since the array is circular, we can go back to the starting element and consider this as subarray. Then again we expand the window, again we expand the window, again we expand the window. Now our pointer comes to the starting position from where we started, right? So we'll stop the execution here. Now forget how we can go from the ending element to the starting element of the array. There's a small trick for that. But you got the intuition, right? Now the tricky part is from end element of array, how can we go to the starting element, right? So basically we have to increment our pointer. So at index 6, if we increment our pointer, then we get our pointer at index number 7, right? So when at index number 7, if we directly modulo it by the size of the array, that is the size of the array 6, 7, right? Now for 7, if we modulo it with the size of array, right, where here the array size is 7, if we modulo 7 by 7, then we'll get 0, right? So basically, when we are at the last index, we can normally increment it, but while incrementing, we should do it modulo n, so that we can go from ending element to the starting element. This is the basic trick, okay? If you knew, well and good, but if you don't, this is how you can achieve the circularity in array, by taking modulo n of the index. Now let's see how the brute force code looks like. So this is the brute force code. That is, for the given function, we are taking the size of array and we have declared our maximum sum to be as minimum as possible so that we can maximize it, right? And we are starting from index 0 and traveling till n. And inside, we have declared current sum to be the array of I. And we have declared j to be I plus 1 and doing modulo n. And you guys know why we did modulo n. And this single element could also be the maximum sum, right? So we have considered maximum sum to be max of maximum sum and the current sum. And inside the loop, till the j pointer doesn't meet I pointer, we are adding array of j to the current sum and trying to maximize the current sum by previous maximum sum or the current maximum sum. And at every instance, we are incrementing j by 1 and doing modulo n. Now this internal execution happens for every index I, right, till it reaches n. And after this execution, whatever maximum is updated will return it. So this was the brute force approach, right? Now congratulate yourself if you got the intuition that you can do this way, because brute force is the underrated skill, right? Now what will be the time complexity for this approach? Since we are running two loops of size n, so the time complexity will be O of n square. And what will be the space complexity? We didn't use any additional data structures apart from the variable side, so the space complexity will be O of 1. So this was the brute force code, right? Now will this code pass? No, because the n value given is 10 to the power of 5. So for n square, it becomes 10 to the power of 10. But a compiler can only execute 10 to the power of 8 instructions per second, right? So here we need to optimize our time complexity. So let's see how we can optimize our time complexity. This array. Now, before moving to optimize the approach, let's consider this array and find an observation here which will greatly help in solving our problem. Now let's consider this part and this part accumulates to the maximum sum subarray. Okay, let me draw it in white line. The array from index 0 to index 2 and from index 5 to index 6. Let me name it as maximum sum subarray, and this to maximum sum subarray, right? Now this whole array sum will be the total sum of the array, right? So let me write it down. The total sum would be the sum of all elements in the array, right? And let's consider this part to be x, that is this part is x, right? Now if we write it in equation, the equation looks like total sum will be the maximum sum plus x. Now if we take x as subject, then x will be total sum minus maximum subarray sum, right? Now if we subtract maximum subarray sum from the total sum, then what will be the x? X will be minimum sum subarray, right? So x will be minimum sum subarray. Now instead of finding the maximum circular subarray sum, we'll find the minimum subarray sum, because if we minimize the minimum subarray sum, maximum subarray sum will automatically increase. Now this was the observation, that instead of finding the maximum circular subarray sum, our intention is to find the minimum subarray sum. And if we subtract minimum subarray sum from the total sum, we'll get the maximum subarray sum. Now one more observation is that if in the array every element is positive element, then there will be no minimum subarray sum, right? So if there is no minimum subarray sum, the whole array will be considered as the maximum circular subarray sum, right? So we need to track the total sum, minimum subarray sum and the maximum subarray sum, right? And from these three parameters, we'll take the maximum of maximum sum or total sum minus minimum subarray sum, right? Now how to find the minimum subarray sum is the new problem. Now whenever you listen about subarray sum, you can directly think of using Kadane algorithm, because Kadane algorithm is used to find the maximum subarray sum, right? But here we need to use the minimum subarray sum. So we'll take the Kadane algorithm logic, modify a bit to find the minimum subarray sum, right? So if you know Kadane algorithm, well and good. But if you don't, I have recently made a video on it where I try to explain it in detail. So you can watch this video. I'll provide the link to this video in the description. Okay. Now keeping in mind that you already know Kadane algorithm or you have watched this video and came back here, let's try run the example. So to find the maximum circular subarray sum, we need to find the maximum subarray sum, the minimum subarray sum and the total sum. And after getting all these variables, we need to take the max of maximum subarray sum and the difference of total sum minus minimum subarray sum. So here I have taken the same example and I have created all the configuration. So maximum sum is negative infinity so that we can maximize it. Minimum sum is the positive infinity so that we can minimize it. And maximum current sum, minimum current sum and total to be 0. Let's start the dry run. Now at index 0, the element is 8. So we'll add 8 to the total first, then to the maximum sum, and then to the minimum sum. Now we'll check whether maximum current sum is greater than maximum sum. Yes, so we'll update it to 8. Okay, and we'll check whether current minimum sum is less than minimum sum. No, but here current minimum sum is greater than 0. So for this case where we need to find the minimum subarray sum, whenever our current minimum sum will be greater than 0, then we'll reset it to 0. That how we reset it to Kadane's algorithm. So this will be resetted to 0. And whenever our current maximum sum will be less than 0, then we'll reset it to 0. Okay. Now, if you didn't understand what did I just say for these 2 points, you probably haven't watched Kadane's algorithm. So please watch Kadane's algorithm first. Now, at index 1, the element is -8. So we'll add -8 to total, then it becomes 0. For current minimum sum, it will be -8. And for maximum current sum, it will be 0. Right. Now we'll check whether current maximum sum is greater than maximum sum. No. But current minimum sum is less than minimum sum. Yes, because -8 is less than infinity, right? So we'll update minimum sum to be 8. Okay. Now at index 2, the element is 9. So we'll add 9 to the total. So the total will become 9 now. Okay. And similarly to current maximum sum, the total will be 9. And for current minimum sum, it will be -8 plus 9, which is 1. Okay. So the current minimum sum will be 1. Now we'll check whether current maximum sum is greater than maximum sum. Yes, right. So we'll update it to 9. Now when we add 9 to -8, then it will become 1, right? Now we'll check whether 1 is less than -8. No. So we'll not update the minimum sum. But the current minimum sum became greater than 0. So we need to reset it to 0, right? So reset it to 0. Okay. Now at index 3, the element is -9. So again, when we add -9 to the total becomes 0. So the total becomes 0. Okay. Now for current maximum sum, if we add -9, then it becomes 0. And for current minimum sum, it will be 0 plus -9, that will be -9. Now we'll check whether current maximum sum is greater than maximum sum. No. Whether current minimum sum is less than minimum sum. Yes. -9 is less than -8, right? So we'll update -9 at the current minimum sum. Okay. Now at index 4, the element is 10. So we'll add 10 to the total sum. For current maximum sum, 0 plus 10 will be 10. And for current minimum sum, -10 plus 10 will be 1. Right. Now we'll check whether maximum current sum is greater than maximum sum. Yes. So we'll update it to 10. Okay. And we'll check whether current minimum sum is less than minimum sum. No. So we'll not update the minimum sum. But my current minimum sum became greater than 0. So we need to reset it to 0. Okay. Now at index 5, the element is -11. So we'll add -11 to total. Then it becomes -1. Okay. And if we add -11 to current maximum sum, it will also become -1. And for current minimum sum, 0 minus 11 will be -11. Here we'll check whether current maximum sum is greater than maximum sum. No. So we'll not update it. But current minimum sum is less than minimum sum. Yes. So we'll update it to -11. And here, since our maximum sum became negative, so we need to reset it to 0. Okay. So what did we observe? Whenever it gets less than 0, we need to reset it to 0. And for current minimum sum, whenever it becomes greater than 0, we need to reset it to 0. Okay. Now finally, at index number 6, the element is 12. So 12 minus 1 will become 11. So we'll update our current sum to be 11. And if we add 12 to the current maximum sum, so it will become 12. And we'll check whether 12 is greater than 10. Yes. So we'll update it to 12. Okay. And for current minimum sum, 12 minus 11 will be 1. So we'll update it to 1. Okay. And we'll check whether 1 is less than minimum sum. No. So we'll not update the minimum sum. But here our current minimum sum became less than 0. So we need to update it to 0, right? So we'll update it to 0. So with this, we have executed our array and we have maximum subarray sum, minimum subarray sum, and the total sum, right? So we'll substitute these values in this formula. So maximum subarray sum is 12. Okay. And total sum is 11 minus minimum sum is minus 11. So 12 comma 11 plus 11. That so it will be 12 comma 22. Now from this both 22 is the maximum sum, right? So 22 is our actual result. Okay. And for this array, if we check our output, it is 22, right? So we have got our output. So this way we have solved our problem. Now since we have understood our dry run 2, let's jump in the code. So here's the code in C++, although the logic remains same. So again for the same function, we have taken the array size, we have declared 5 variables. Maximum sum to be minimum, minimum sum to be maximum, current maximum sum, current minimum sum, and total sum to be 0, 0, and 0. So here we are running a loop from 0 to n, and inside we are doing 3 steps. The step 1 is this, the step 2 is this, and the step 3 is this. Okay. So in the step 1, we are adding array of I to the total sum. Okay. And in step 2, we're adding array of I to the current maximum sum, and maybe this could be potential current maximum sum, right? So we're updating maximum sum to be maximum sum and current maximum sum. And whenever our current maximum sum less than 0, and whenever our current maximum sum gets less than 0, then we are resetting it to 0. This is the glance of Kadane algorithm we were using. And similarly in point 3, we are adding current minimum sum to be array of I. And here also this could be potential minimum sum, right? So we are updating minimum sum to be minimum sum and current minimum sum. And here if current minimum sum is greater than 0, then we are resetting it to 0. So in this case, when it gets less than 0, we are resetting it. And here when it gets greater than 0, we are resetting it. And after this all execution, the result could be the maximum of maximum sum or the total sum minus minimum sum. So the code is pretty basic, right? But the observation from where we started, how we approached the brute force solution, how we optimized it, was a great learning, right? Now, what will be the time complexity for this approach? Here we are running a single for loop of size n. So the time complexity will be O of n. And what will be the space complexity? Here also we are just using 5 variables. So the space complexity will be O of 1. So here we have optimized our time complexity from O of n square to O of n. Okay. So this was the video. I hope you guys liked this video. If you really did, then please like, share and subscribe to my channel. If you have any query, please comment it down. I'll try to respond to it as quickly as possible. And if you have any feedback for my teaching, please comment it down too. I'll try to improve on it. So see you guys tomorrow solving any other coding problem. Till then, stay safe, stay happy and peace.